Hey, I'm going to do the Physics Unit 1 review. You can use this to check your answers and get some reinforcement if there's any things you feel a little bit weak about. Let's see. If I'm going to convert from centimeters to kilometers, you might be just like a decimal mover. That's okay if you can do that consistently. I'm going to show you the way that I do it, or I'm going to do it the same way as I showed you in the video. So let's see, I've got 3.02 centimeters. I put that over 1, and then I don't want centimeters. I want to go to meters first, so that's 10 to the negative 2, and then I don't actually want meters, so I can put that down there. I want kilometers, and the K means 10 to the third, right? So all I have to do there is go 3.02 times 10 to the negative 2 divided by 10 to the third. And now my calculator is it's in normal mode, but it decided to give that to me in scientific notation anyway. Sometimes your calculator will do that. If it's not, if your calculator doesn't give it to you in scientific notation, but you would like it to be, just go into the mode, hit mode, and you can go over to that. If you've got some other kind of calculator, there should be somewhere where you have an option to go to that SCI, that Psi mode. So 3.02 times 10 to the negative 5. Notice that I didn't write that E there. That's calculator jargon. That E means times 10 to the, and I'm going to write that. Okay. Please don't write the E. That's calculator speak. All right. Let's crank through these now a little faster. 0.110 milliseconds. I don't want milliseconds. I want seconds. And milli means 10 to the negative 3. So I just have to do 0.110 times 10 to the negative 3. And that gives me 1.1 times 10 to the negative 4. If I didn't have the units here on the test, if it says convert to whatever, you would need to include the units. With these little blanks, I put the units here, but all of our numbers in physics all the time need to have units. All right, next one. I've got 14.2 kilograms. I want to go to milligrams. So first thing, I'm going to get rid of the kilo. Kilo means 10 to the third, but I don't want grams. I want milligrams, and milli means 10 to the negative third. Do those cancel each other out? No, they don't. So 14.2 times 10 to the third divided by 10 to the negative third. Okay, now that, you can go ahead and count the 1, 2, 3, 4, 5, 6, 7. 1.42 times 10 to the 7th. You can do that. If you don't want to take any chances counting those over, you feel like you might make a mistake, then go ahead and do what I was talking about. Go into scientific notation mode and go back to your home screen and hit enter again. And there it is. 1.42. Oh, this is the same question. Oh, almost. But this is 1.42 instead of 14.2. So that's just going to be 1, because I'm going from kilo to milli again. So that's just going to be 10 to the 6. And I think you're probably okay with that, if I don't do that one for you. And then how about meters to kilometers? 3.021 meters. Want to go to kilometers. K means 10 to the 3. So 3.021 times 10 to the negative 3, well, that's just, or divided by 10 to the 3, that's the same as times 10 to the negative 3, if you remember what negative exponents mean from math class. So there you go. Sorry, I meant to do divided by. That's not supposed to be there. There you go. 3.021 times 10 to the negative 3. Millimeters to centimeters, that's just one place different. You can try setting that up, but you should get a couple different ways you could write it. Maybe 7.21 times 10 to the negative 1 centimeters. I would also be okay if you wrote that as 0.721 centimeters. Either of those is okay. Grams to milligrams. This will be, I guess it's the last one of these. I'll go ahead and set it up for you here. So 0.502 grams over 1. I don't want grams, I want milligrams, and milli means 10 to the negative 3. So 0.502 divided by 10 to the negative 3. 5.02 times 10 to the 2. All right. The next ones are a little bit trickier. You can expect to see some like this on your test. 603 miles, I want to change that to kilometers. And I'm giving you here 1 mile is equal to 1,609 meters. I personally think that this is a conversion that people who use miles, like us, should know. Most of the world is on the metric system, so I think it's our responsibility to know this kind of stuff. We tend to be very, very, I don't know, we tend to think like, we tend to forget, I think, sometimes as Americans that there is like a rest of the world out there, and that we are like just one of many, many countries. So it's like hilarious, for example, that like some people think the coronavirus thing is a hoax that's like about like U.S. stuff when it's like all over the world. And it would be pretty funny if the whole world would like play along with the with that hoax just to make us happy or whatever. I don't know, crazy. A lot of crazy people out there. So 603 miles. I don't want miles, I want kilometers, but I think I'm going to have to go to meters first here, right? So 1 mile, 1609 meters. And then I want to go from meters to kilometers. That's 10 to the third is what that kilo means. So it looks like I need 603 times 1609 divided by 10 to the third. Let's do that. 603 times 1609 divided by 10 to the third. And that's in scientific notation, 9.7 times 10 to the 2. That is perfectly fine. That's also 970. So either one of those, that's how many kilometers that is. All right. How about when the units are squared like this? Remember, you got to square the conversion factors when you do this kind of conversion. So I got 0.213 square meters. I would like to go to centimeters, and the C is 10 to the negative 2, but I got to square, if I want square centimeters, I got to square that also. So that's the tricky part that people mess up right there. So 0.213 divided by 10 to the negative 2 squared. 10 to the negative 2 square. Let's see. I think to be safe, if I were you, you might have that little. You might have a newer calculator than this where you can make it look like a little fraction. That's nice if you do. I don't have that option here. So I'm going to do 10 to the negative 2 and then squared, like that. Or you could do to the 2. That means the same thing. But there is a little squared button there. Okay, so that is 2.13 times 10 to the third, or 2,130 square centimeters. And here I have like a compound unit. I've got kilometers over hours. So I'm just going to use a little bit of this space down here. 76 kilometers 1 hour. So I have to pick. I would like to have meters instead of kilometers. I'm going to deal with that first. You could deal with the hours first if you want. So kilometers I don't want, meters I do. The K means 10 to the third. So I'm good there, and I got my meters. And then 1 hour, do you know how many seconds there are in an hour? There's 60 minutes by 60 seconds. So 60 times 60 is how many? There's, back to normal mode here, 3,600. That's how many. That's a good thing to know. Of course, you could just go to minutes and then go to seconds from there. But if you know 1 hour, how do I know to put the hour on top there? Because it's on the bottom, and I need to cancel out. So that's 3,600 seconds. Okay, so I need to do 76 times 10 to the third divided by 3,600. It's 21. 21 meters per second. All right. There's all your answers for that. What's the SI unit for mass? Mass is the tricky one that that's the most often missed because people will put gram there instead of kilogram. The SI unit for mass is the kilogram. It's weird that it's got the prefix, but it's because a gram's so small. It's not a good like human scale unit to be the base unit. What is the SI unit for time? It is the second. And for length, it is the meter. And you can use those abbreviations because those are the correct abbreviations. If you want to write out meter, second, kilogram, that's fine too. In the bunch of objects lab, the independent and dependent variables, the independent variable was the number of objects, whatever the objects were. So you had like little washers or little nuts or other little hardware bits. The dependent variable was the total weight. You could just call it weight there. I'd be okay with that. Now, what about things that we kept constant? If you struggled thinking about this, the thing that we kept constant was the container. And like if you changed the container every time you added some objects, that would have messed things up. You didn't change the type of object. That would have messed things up. There's two. There might be some other things you could think of that we also didn't change. But that's two good ones. This is two that spring to my mind right away. How can you identify the IV of an experiment? So this is the variable that we change directly. There's other ways of saying that I think are fine. You could say it's the variable that we have control of, or something like that. So if you said something slightly different but you feel like it means the same thing, you are probably right. How can you identify the DV, the dependent variable? The dependent variable changes in response to our changing the independent variable, or something like that. Whoa, sorry, that was crazy. It's the response variable. And I think actually that's the end of this. Here I'm going to do a quick video for that, just to make sure that we're all good.